Good morning, everyone. Welcome to the science class. Children, as you know, we have completed our chapter number 12 in the last classes. So today we are going to start our new chapter number 13, Motion and Time. Motion and Time. In this chapter, we are going to see today introduction part of the chapter. Then we will see about some types of motion, slow or fast movements, and we'll do reading of page number 143 and 144. So, before starting chapter, let us see an introductory video to understand the content of the chapter.
Introduction. Look around yourself and you will find objects of different kinds such as television, mobile, trees, cars, buses, trains, etc. Objects such as television, mobile, trees, etc. are static. In other words, their position does not change with time. Such objects are said to be at rest, whereas objects such as cars, buses, trains, etc. are non-static. It means that their position changes with time. Such objects are said to be in motion. Let us discuss motion and time in greater detail in this lesson. Objectives. At the end of this lesson, you will be able to differentiate between slow and fast motions, define speed, measure speed, identify the units of speed, measure time. Suppose you have an appointment with your doctor at 5 in the evening. It is already 4:30 p.m. and the doctor's clinic is 5 kilometers away from your house. You have the choice of either cycling down or taking a taxi to the clinic. What will you do? Correct. You will take a taxi because a taxi is faster than a cycle. So we can say that some objects move faster than others. Now the same taxi moves fast on an empty road and slow on a busy road. Thus, the same object can move fast at one time and slow at another time. The next step is to identify whether an object is moving faster or slower than another object. To do that, you must calculate the distance covered by both the objects in the same time interval. Consider a 1,000-meter cycle race. When the whistle blows, the race begins. Every cyclist starts at the same time. Suppose after 10 minutes, one cyclist reaches the finishing line. This means that the winner covered the distance of 1,000 meters in 10 minutes. This also means that all the others who reached the finishing line later covered less than 1,000 meters in 10 minutes and hence lost the race. So we can say that the object that covers a longer distance in a given time interval than other is faster. The most convenient way of finding out which object moves faster than the others is to calculate and compare the distances covered by all the objects per unit time. The object that covers a greater distance per unit time is quite obviously faster. The distance covered by an object per unit time is called the speed of the object. Suppose your brother claims that his motorbike is faster than his friend's. His friend denies. You know that your brother's motorbike covers a distance of 60 kilometers in an hour, whereas his friend's bike covers 40 kilometers in 1 hour. Let us now check the claims of your brother and his friend. The speed of your brother's bike is 60 kilometers per hour, and that of his friend's bike is 40 kilometers per hour. Your brother's bike is certainly faster than his friend's because its speed is greater. To measure the speed of an object, we measure the distance covered and time taken to cover that distance by the object. After that, we apply formula of speed. Let us learn to measure speed with this simple exercise. Draw a line. Ask a friend of yours to stand on the line. Allow him to run till he wants to stop. Note the total time taken from the moment he started to the moment when he stopped. Measure the distance covered by your friend. Now divide the distance covered by the time taken to cover the distance. What you have calculated is the running speed of your friend. Do the meters and indicators in front of the driver's seat of your father's car scare you? Now they won't. Straight beyond the steering wheel are 2 meters. The circular dial, which looks somewhat like a clock with needles and numbers, is the speedometer. When the car is in motion, one needle points to a particular number in the speedometer. This number is the speed of the car in kilometer per hour. There is also a rectangular box within a speedometer that has digits written on it. When the car is in motion, these digits undergo a change, rather increase. This rectangular box is known as the odometer. Its readings show the distance covered by the car. Have you ever wondered how our elders could tell the approximate time of the day by just looking at the shadows? Many events in nature repeat themselves after definite intervals of time. For example, sun rises every day in the morning. The time between one sunrise and the next is called a day. Similarly, a month is measured from one full moon to the next. 1 year is the time taken by Earth to complete one revolution of the sun. To measure intervals of time, which are shorter than a day, we use clocks and watches. The basic unit of time is second. Its symbol is S. Larger units of time are minutes and hours. 1 minute is equal to 60 seconds, and 60 minutes are equal to 1 hour. The basic unit of speed is meter per second. We can also express it in other units such as meter per minute and kilometer per hour. We write the symbols of all units in singular. Summary. Let us summarize what we have learned. Some objects move faster than others. The object which covers larger distance in a fixed time interval move faster than other. The distance covered by an object per unit time is called the speed of the object. Speed is measured in kilometer per hour or meter per second. Speedometer measures the speed of a vehicle and odometer shows the distance covered by it.
I hope you understood from this video what we are going to learn in this chapter. As we have started, children, we have to learn about the different types of motions and their measurement. So you know what is motion? It is a change in position of an object with time. There are different types of motions that you have already learned in your 6th standard. Motion along a straight line, which is called as rectilinear motion, like motion of a car on a straight road. Periodic motion, motion of a pendulum back and forth, and circular motion, motion of earth around the sun. Children, in class 6 you have learned these different types of motion, and one example table was given to you to identify the different types of motion that we have done. Soldiers in march past, straight line. Bullock cart moving on a straight road, it is also showing a straight line motion. Hands of an athlete in a race, it is periodic. Paddle of a bicycle, circular. Motion of the earth around the sun, circular, periodic. Motion of a swing, it is periodic, and motion of a pendulum is again periodic. Now what is slow or fast motion? We know that some vehicles move faster than others. Even the same vehicle move, we have just seen in the video that they can move faster than each other. So here we had one picture, children, in the book that we have discussed. There was an activity where it was showing the position of some cars in the picture. In the first picture, there are the positions of some cars. You can see here. And this is the position of the car after 5 minutes. Now let us try to find out the distance of the car up to which they have moved. The first car was having the starting position and the end position here. This much distance is covered by it. So in the similar manner, I have taken out the starting point of all the cars. Let us see. First car, you can see the distance cover is very less. Second car, white one I have taken. The distance cover is more than the first one. For the third car, again it is very less distance. For the fourth car, a small distance like the first car only. For the fifth car, you can see the distance here is more, isn't it? Let us try to find out the next. For this car, the distance is less, and for the next car again, white one, the distance is this much. And for the blue car, distance is this much. We have not taken the first car because it has already gone from the picture. So let us see now the distance covered by them. For the first car, up to this much. Second car also. Third car. Fourth car. Fifth, sixth and seventh. Children, from here you can conclude that this green color car has performed the longer distance, has gone to the longer distance in comparison to the other one in the same time interval. So can we say that this car is faster than the other one? Yes, we can conclude that the green colored vehicle covered the longest distance at a particular time. So the distance moved by object in a given time interval can help us to decide which one is faster or slower. For example, children, if you have gone to see of your friend at the bus stand and you are pedaling your bicycle at the same time the bus begins to move, what will you do? The distance covered by you after 5 minutes would be much smaller than that by the bus. So can we say that bus move faster than bicycle? Yes. We also often say that the faster vehicle has higher speed. So in a 100-meter race, it is easy to decide whose speed is the highest. The one who takes shortest time to cover the distance. So children, by measuring the distance and the time, we can find out which object is moving faster or slower. So this is what all about the topic slow and fast today. We will learn more topic about the chapter in the next video. Till that time, you should read page number 143 and 144 as an assignment. We'll meet you in the next class, children. Feel free to ask your query if you have. Take care of yourself, stay safe, stay home. Thank you, everyone.